we're distributing a fraction today, so we're working along with our distribution property lesson, and we're going to do fractions, and then we're going to work backwards given a quotient to utilize the distributive property. Distributing a fraction, I need you to remember that you go top times top over bottom times bottom. That's how you distribute a fraction. You go top times top over bottom times bottom. You learned that last unit and the unit before and a long time ago. So the first thing I always do is turn it to negative, plus a negative. And then I'm going to put a 1 on the bottom so I know what the top is and I know what the bottom is. Bless you. Now I distribute. Negative 3/4 times x is negative 3/4 x plus top times top over bottom times bottom. Negative 3 times negative 8 is 24 over 4 times 1 is 4. Then you have to simplify. This would be negative 3/4 x plus 6. Final answer. Okay, next one. I'm going to plus a negative, and then I'm going to make a denominator. That way I know what I can go top times top over bottom times bottom. So, 2/3 times 1/2. I'm going to go 2 times 1 is 2 over 3 times 2 is 6x plus top times top over bottom times bottom. 2 times negative 9 is negative 18 over 3 times 1 is 3. Now the last part you have to simplify. You have to make it look pretty. So this would be 1/3. That would just be negative 6, wouldn't it? 18 over 3 is 6. So it's 1/3 x plus a negative 6. Best way, 1/3 x minus 6 is our simplified answer. Okay, the next application of the distributive property is another working backwards one, where we can write one fraction as a sum or a difference. So notice if I have 1/2 plus 3/2, can I turn that into 1 plus 3 over 2? Do you agree with that? Okay, now use your knowledge there that you agree with that. Then if I have 2x plus 7 all over 5, then what do the 2x and 7 share in common? The denominator of 5. So I can rewrite this as 2x over 5 plus 7 over 5. And that would be your final answer. Okay, so our purpose there, well, really we're prepping you up for graphing in slope-intercept form, identifying slope, identifying y-intercept. You need to be able to break something up sometimes. So 8 minus 9x over 3, what do they have in common?
3.
The 3. So I'm going to break it up. 8 over 3 minus 9x over 3. Okay, well I can't simplify 8/3, so I'll just leave it as 8/3 minus, what's 9 over 3? 3x. And there you go. That's it. The other stuff we talked about yesterday, that's a distributive. Notice that they both had the 4 in common here. So we turn this into 4 times 5 plus a negative 6 would be negative 1, negative 4. Remember, we did that yesterday with some examples. Here they shared a negative 5. So I turned it into negative 5 times. Or what am I? No, this is not an addition one. This is a mental math one. This would be negative 5 times 2 is negative 10. So I have negative 15 times 10, negative 150. That's not even applying the distributive property. I don't know why I wrote that one down. It's not even really applying. That's applying our mental math, the commutative property. That's what that was applying. Okay, so I'm going to show you a geometric connection to the distributive property. I didn't put this in your notes, so you'll want to write a little subheading. I do want you to know that area is equal to length times width. Do you agree with that?
Yes.
Okay. So what you're going to notice today, if you have a rectangle, and I want you to create an expression that models the area of the rectangle, you multiply them. So this, let's call this side 5 and this side 2x minus 20. And if I asked you to create an expression that models the area. Well, I know area is length times width. And I personally always get my length and width messed up. I don't know which one's which. Notice that commutative property doesn't matter. It doesn't matter which one I put first. So the area of this would equal 5 times all of that, not just the 2x. You have to specify that you need to times 5 to everything. And in order to specify that, 5 needs to be sticking to the whole expression. Now I know that I need to multiply 5 to everything. So then my algebraic expression that models the area of this rectangle would be 10x plus a negative 100, or 10x minus 100. So notice, area, just to summarize, area of a rectangle is length times width. To find the area, you do the length times the width. If the width is more than one term, you need to make sure that you put parentheses around there so you know that you have to times 5 to everything inside. 5 is not only, it's not, if we wrote it like this, what does order of operations tell you to do? Yep, 14x minus 20. Are they the same thing? No, it's completely different. That's why you definitely need to make sure that you include that parenthesis. I have no idea. Why would I get 14x? Where did that even come from? 10x. I don't know where 14 came from.